All right, here we go. Proving quadrilaterals are parallelograms. What do we have here? We've got AB congruent to CD. We've got BC congruent to AD. So in essence, we're really showing that if a quadrilateral has both pairs of opposite sides congruent, then it must be a parallelogram. And a parallelogram, this says it in symbols, a parallelogram has both sets of opposite sides parallel. Let's put that here. Both pairs, I guess I should say, pairs of opposite sides parallel. Where are we going here? Let's see. Okay, statements, reasons, step 1, AB congruent to CD, BC congruent to AD, given. The marks are in there, thank you. Oh man, we've got fused triangles. That is just begging to say that AC is congruent to itself. You're probably going to use congruent triangles, and if you've got two sides and then these triangles are glued together, by the reflexive property, AC is congruent to itself. Then, boom, 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 we've got SSS. Let's be careful on this congruent statement. Triangle, let's see, ABC. ABC is congruent to triangle. It's got to be the side that is in between 1 and 3 marks. So it's going to be 1 and 3 marks there. CDA. And that's because of SSS. Now, what do we typically always do after we have congruent triangles? Well, you've got all of those corresponding parts of congruent triangles are going to be congruent. So, change the color here, and we've got, let's see, I want to show that those sides are parallel. I'm going to focus on these flat ones that, as we see, are flat first, and this transversal. I look for the Z. The Z happens right here. This angle and that angle are congruent. So angle BCA is congruent to angle DAC because of CPCTC. Now, why do we need that? Because line 5 says if we have two lines that are cut by a transversal and alternate interior angles are congruent, you have lines parallel. So now we can say BC is parallel to AD because of the converse, really, of the alternate interior angles theorem. ERSE. All right, so now I'm going to clean it up a little bit just to be clean, and I'm going to put these parallel marks here. Now I'm going to switch my focus to these lines and the same transversal, but in those, let's see. Oh, you know what? I've got alternate interior angles. Or sorry, I don't need that. I have this angle is congruent to this angle because of CPCTC. So in line 6, I know that angle, let's see, angle BAC is congruent to angle DCA or ACD, DC. And that is because of CPCTC. The triangles are congruent. I can still claim that the corresponding parts of each of them are. And now that I have those, now I've got, I'll switch it to highlighter. The Z happens right here. See that? when parallel lines are cut by when two lines are cut by a transversal and alternate interior angles are congruent, I know that those lines are parallel. So I know that now AB is congruent to CD because of converse of the alternate interior angles theorem. Now I have proven that both of those happened. The first one happened here in line 5. And A, B, and C, D I just did. If you want to really be schmancy, you want to say that A, B, C, D, A, B, C, D is a parallelogram. That clinches it because of definition. Both sets of opposite sides are